So there are three rules that guide us on how electrons fit into these orbitals of 1s, 2s, 2p, etc. And so these are the three rules to know. Now, the names of the rules, I don't care. No one cares that you know the name. But what they're saying is what's important to know. So the first one is called the Aufbau principle. And all these principles are named after the people who came up with it. So Aufbau is a principle that states that when electrons go into orbitals, they go into orbitals of the lowest energy first. And when those are full, they go to the next one. And when those are full, they go to the next one. It's like filling water, putting water into a glass. It fills the bottom, and then when that gets full, it goes to the next level, the next level, the next level. So the Aufbau principle is pretty straightforward. The next one is what's called the Pauli exclusion principle. Again, Pauli was a scientist, and something gets excluded. So the Pauli exclusion principle says that electrons rather be by themselves than share an orbital with another electron. Now, there's two electrons that fit per orbital. Two electrons can fit per orbital. If there's no other choice, they have to fit into the same orbital. If they have a choice, they'll go into another orbital because they can repel. But if they have a choice, if they don't have a choice, what they end up doing is getting into that same orbital, pairing. But electrons, when they go around the orbital, in the orbital around the nucleus, not only do they go around, but like the Earth going around the sun, not only does it go around, but it also spins. Well, when you have an electron spinning, it creates a magnetic field. And like if you have two magnets, and you put two magnets together at the same poles, they resist. And what one does is it flips and then it attracts. So electrons are the same thing. When electrons are spinning and they have the same spin, they have the same magnetic situation going on. And so that's repelling them. So what they do is that one of them will flip the way that it spins. So they'll spin in opposite directions, and then they can get closer together, sort of like attracting. So, and that's how they can be in the same orbital. So when an electron has to be in an orbital, it rather be in the lowest energy orbital first. If there's no choice but for it to pair, then it'll pair with opposite spin. And I'll show you later how you write that down. And then the last rule, which is called Hund's rule, says that when electrons can occupy multiple orbitals of the same energy, they're going to fill in those orbitals by themselves. So if you have for example, two orbitals that have the exact same energy, and you have two electrons, one electron will fit into one orbital, one will go into the other with the same spin because they have the same energy. Now, why would they do that? Because they repel, and it doesn't take any more energy for them to go into another orbital if they have the same energy. If they don't have the same energy, then they can't do that. Then they have to pair. But if all those options are of having the same energy orbitals that they can be by themselves is gone, then they have no choice but to pair according to the previous principle. So those are the ideas and how electrons fit into orbitals. The Aufbau principle says they go into lowest energy orbitals first. The Pauli exclusion principle says that when you have electrons going into orbitals, they have to have opposite spin. And Hund's rule states that when you have electrons that can go into multiple orbitals of the same energy, then they can go into those orbitals with the same energy by themselves, with the same spin. But if those are all full, then they have no choice. They have to pair up with opposite spin. And those are the three rules of the road, if you will, for electrons going into orbitals.